Hi, I'm Detective Incognito. Welcome to another investigation. I explore strange events, forgotten discoveries, and questions that still challenge what we know about our world. What you're about to hear might change the way you see everything. In 2013, Japanese scientists accomplished something that seemed impossible. They read people's dreams, not through symbolic interpretation or psychoanalysis, but by literally predicting what sleeping subjects were seeing. With over 60% accuracy, they decoded visual dream content directly from brain activity patterns. This breakthrough revealed something profound that connected human consciousness to artificial intelligence in ways nobody anticipated. Subscribe now to discover how your dreams and AI systems speak the same visual language, and what this tells us about the nature of perception itself. Like this video if you've ever wondered whether machines and minds might work more similarly than we realize. In 2013, researchers at the ATR Computational Neuroscience Laboratories in Kyoto, Japan, published findings in Science that would reshape understanding of both dreams and artificial intelligence. Yukiyasu Kamitani and Tomoyasu Horikawa designed an experiment that required extraordinary dedication from participants. Subjects slept inside functional magnetic resonance imaging scanners while wearing electroencephalography caps. Over the course of 2 years, each participant was awakened approximately 200 times. When brain activity indicated they were dreaming, immediately upon waking they reported what they had seen. The researchers categorized these reports using WordNet, comprehensive lexical database that organizes concepts hierarchically. Before attempting dream decoding, the team spent months training machine learning algorithms on each subject's waking brain activity. Participants viewed thousands of images, while researchers recorded which patterns of neural activation corresponded to seeing cars, buildings, people, or natural landscapes. The critical test came when they applied these decoders to brain scans captured during sleep. The algorithms predicted dream content categories with remarkable accuracy, exceeding 60% for many object classes. When subjects reported dreaming about keys, their visual cortex showed patterns matching waking perception of keys. Dreams of buildings activated brain regions consistent with viewing actual architecture. The sleeping brain, it appeared, was processing visual information, using the same neural machinery employed during waking perception. In 2017, the research team published additional findings that revealed the connection to artificial neural networks. They incorporated deep convolutional neural networks into their analysis, specifically using architectures like Krzyzewski's AlexNet. That had revolutionized computer vision. What they discovered was striking. The brain and artificial neural networks process visual information through virtually identical hierarchical structures. Both systems build understanding progressively. Early layers in neural networks detect simple features, like edges and basic shapes. Intermediate layers recognize textures and color patterns. Deep layers identify complete objects and complex scenes. The human visual cortex operates through an analogous hierarchy. V1 processes basic features. Higher areas like V4 and inferior temporal cortex recognize objects. During dreams, this entire hierarchy activates, just as it does during waking vision. The correspondence wasn't metaphorical. By mapping deep network layers to brain regions, researchers could predict dream content even more accurately. The network's intermediate layers corresponded to intermediate visual areas. Deep layers matched high-level object recognition regions. This meant that artificial neural networks weren't merely inspired by biological vision. They had independently converged on the same computational solution to visual processing problems. Dreams engage this system without external input, generating imagery through internal activation of the same pathways used for perception. This parallel revealed fundamental insights about consciousness and computation. Dreams aren't random neural noise. They follow the same hierarchical feature organization that structures waking perception. This suggests perception itself is active construction, rather than passive reception. The brain continuously predicts what it expects to encounter, based on learned patterns. During waking hours, sensory input constrains these predictions. During sleep, the prediction machinery runs unconstrained, generating imagery from internal models. Without external verification, artificial neural networks operate identically. They don't passively classify images. They actively construct interpretations, based on learned feature hierarchies. When networks like Deep Dream generate imagery, they're running the same prediction machinery, without external input constraints. Both biological and artificial systems are fundamentally predictive processing architectures. Understanding this changed how neuroscientists think about consciousness. If dreams use the same neural mechanisms as perception, then perhaps consciousness itself emerges from predictive modeling. What we experience as seeing might be our brain's best guess about external reality. Constantly updated by sensory evidence, dreaming reveals this process operating independently. The implications extended beyond understanding dreams. By 2017, the ATR team demonstrated their decoders worked for imagined objects, recalled memories, and even abstract concepts. They published findings in Nature Communications, showing a generic decoder could reconstruct visual content. Whether subjects were viewing, imagining, or dreaming, this suggested all visual cognition shares common neural substrates. Applications emerged rapidly. Brain-machine interfaces could potentially allow locked-in patients to communicate. Through imagined imagery, understanding visual processing hierarchies improved artificial vision systems. The convergence between neuroscience and artificial intelligence accelerated, as each field informed the other. Researchers recognized that studying how brains process dreams could reveal principles applicable to making AI systems more robust. Conversely, insights from neural network architectures guided new hypotheses about brain function. The boundary between biological and artificial intelligence research dissolved. As scientists realized, they were studying variations of the same computational principles. What the dream decoding experiments ultimately revealed transcends their immediate technical achievements. They demonstrated that biological and artificial neural networks aren't merely analogous. They're homologous. Having converged on identical computational solutions to visual processing challenges. Both construct rather than record reality. Both operate through hierarchical feature extraction. Both generate imagery through the same mechanisms, whether processing external input or running internal simulations. Dreaming represents what occurs when the brain's predictive machinery operates offline, freed from sensory constraints, yet following the same computational logic. This parallel suggests consciousness itself may be a computational process. We're only beginning to characterize formally the fact that artificial systems can partially replicate aspects of subjective experience, like visual imagery, doesn't diminish human consciousness. Instead, it reveals that consciousness might be understandable through the same frameworks we use to understand computation. Scientists continue debating the philosophical implications. Does similarity in processing suggest similarity in experience? Researchers emphasize we're witnessing convergent evolution between biological and artificial intelligence. Both face the challenge of making sense of visual information. Both discovered that hierarchical predictive processing provides elegant solutions. When you dream tonight, your visual cortex will activate in patterns nearly identical to waking vision. Those patterns follow the same hierarchical logic that artificial neural networks employ. The machinery that lets you see and the machinery that lets you dream are one and the same. And that machinery operates on principles we're finally learning to formalize and replicate artificially. Understanding this connection transforms how we think about minds, machines, and the computational nature of consciousness itself. If you liked what you just saw, like the video, subscribe to the channel and activate the bell. Leave your opinion in the comments below to let me know what you thought. Thanks for sticking around and see you in the next video.